Hi everyone, this is Mrs. Coiler. I'm going to be showing you how to do the gravity force lab, the effective distance on gravity today. There are two parts of this lab. This is the first part. We're focusing on distance. The other part will be focused on mass. So the first thing you need to do for this lab is get your notebook page ready. You need to check the instructions in Google Classroom. There is a doc that has all of this information in there, so get your notebook page ready first. None of this is going to make sense until you do that. All right, so the next step is you have to go into PhET. You need to find the gravity force lab. We're using the one that is not the basics one. It's just the gravity force lab. It's the one with the white background. So we need to open that up. And what we're going to do first is in the lower right, we need to click on scientific notation. Right now it's in decimals. So these numbers are going to be hard to read because they're so tiny. Scientific notation is going to help us with that. So what we see right now is 1.67 times 10 to the negative 7. What that means is that we scooted the decimal point over 7 times in order to get a number that looks more manageable. So that negative 7 just means like we had to scoot that decimal point over. All right, now we're on number 4. So what step 4 says is to set your masses to 105 kilograms. So both of your masses need to be at 105. So mass 1 is going to need to come up 5 kilograms, and mass 2 you're going to need to bring it on down because it starts at 400. We need to bring that down to 105. So that's going to be constant for every single trial, because in this part of the lab, we're focusing on distance. Now we need to fill in our data table. So we're going to start by setting up our masses at the locations that it specifies. The first row says we need to have mass 1 at 1 meter and mass 2 at 9 meters. And then what we're going to do is take a look at the force on mass 1 by M2 above the blue circle, and we're going to look at force on M2 by M1 over the red circle. And those are what we need to write in our data table. So if we look at our data table, we've got our locations as 2 columns, and then we've got distance between objects. You need to write how many meters are between each object. So right now, 9 minus 1, we've got 8 meters between our masses right now. So that's something we need to do starting off. And then the next column over, force on M1 by M2, we see that above the blue circle. So what we see there right now is 1.15 times 10 to the negative 8. Now, since the column on our data table already says times 10 to the negative 8th power, we don't need to write that on the data table. So what I'm going to write in the column for force on M1 by M2 is just 1.15. I'm going to do the same thing for force on M2 by M1. That's interesting. They're the same number. Well, we're going to keep that in the back of our mind. We're going to add it to the conversation later on in this standard. So what you do next, you're going to move it to about 1.5 and then 8.5. You'll get those numbers, and then you're going to keep moving these to where the data table tells us to. Then you need to create a line graph when you've gotten all your data. The distance between the masses is going to be on the x-axis because that's what we were changing between our trials. And what's going to be on the y-axis is the force on M1 by M2. So you're going to need to put your numbers on there. You don't need to put times 10 to the negative 8th as long as that's in parentheses on the label for that axis. Let me know if you have any questions, and I will see you next time. I'm going to show you how to set up the graph for the effective distance on gravity. So what we have here on our y-axis is the force of gravity. Keep in mind we've got 10 to the negative 8 here, so that makes our numbers a lot nicer looking. It's going to make them easier to graph. So I just went from 0 to 10, and I went up by 0.5s because we have so many decimals. That's going to make it easier to graph our points. On the x-axis, we have different, distance between masses. So we went all the way up to 8 for that. So just to spread out the graph, I went up by 0.5s. And otherwise, our graph would have been really smashed. It would have been very strange looking. So just to space it out, make it a little bit bigger, try to fill our page of graph paper here, I went up by 0.5s all the way from 0 to 8. Now plot your points and keep those in mind. We're going to do the effect of mass on gravity next, and we're going to compare those two graphs. So be ready for that. Keep an eye out for that video. I hope you have a great day, and please let me know if you have any questions.